Hey there, my name is Valdemar, and in this three-part video series, we're looking at these three types of boxes that are typically used when recording guitar. Let's check it out. Today, we're doing a deep dive into the Reamp box. This whole series was actually inspired by a discussion on a recent Glenn Fricker video. Let's start by looking at what he had to say about Reamp boxes.
Glenn, could you please do a short tutorial of Room EQ Wizard? What do we need to make it work? A measurement microphone with a calibration file? Do I need that, or I just use an old mic? Do I need a Reamp box, or can I use my interface somehow? Behringer Euphoria, blah, blah, blah. How do we set it up and test things with it? I would really like to be able to test some things. Can you help?
Yes, you need a Reamp box, so quit trying to dodge it there and just fucking go get one. Because you can use this for a lot more than just running tests. You can use it to reamp your takes through various amps and whatnot. This will save you a lot of grief. You can learn an awful lot by getting one of these. So quit making excuses and just fucking buy one already.
Now, I absolutely love Glenn's content. He's my favorite angry Canadian. But in this case, I thought his answer was a bit too simplistic, and I thought I could give a bit more of an in-depth response. A Reamp box is a really helpful tool to have, but you absolutely can do reamping without one, and I'm going to show you why. In short, a Reamp box takes a balance signal from your recording interface, passes it through an isolation transformer, and provides you an unbalanced output signal that you can connect to your amplifier. Many Reamp boxes also state that they impedance match your signal for the amp, a claim we'll get into in a bit. Well, let's start by taking a look inside one, shall we? This is a passive Reamp box from Radial Engineering, who I believe actually own the trademark to the phrase Reamp. Remember kids, it's only a Reamp box if it's from Radial, otherwise it's just a sparkling transformer unit. As this is a passive box, it does not contain any buffers, transistors or amplification components. Radial helpfully provide a block diagram of the unit which we can use as a reference. Our balance signal comes into the unit and goes into the transformer. The transformer serves a dual purpose. It's used to convert the balance signal to an unbalanced one. Second, if we engage the ground lift button, it decouples the ground connection between the audio interface and the amp we're connecting to. Next, the signal goes through a volume pot and a high Z output module to mimic the output impedance of a guitar pickup. Let's think about why these features are beneficial for a moment. Being able to work with a balance signal from the audio interface provides us better noise rejection. A balanced signal is much less susceptible to electromagnetic radiation, because any radiation that interferes with the signal will affect both the positive and the negative phase of the signal equally. So, when the signal is converted back to an unbalanced signal, almost all of the noise cancels out and we're left with only our original signal. Very clever trick. Second benefit is the fact that a balanced signal has about 3 dB better signal-to-noise ratio. This is due to how the signals are summed up at the end of the signal chain, where we effectively double our signal strength, but any random noise that's been added does not sum up linearly, because part of the noise cancels out between the positive and the negative phases. We end up with a better signal-to-noise ratio as a result. Note that we're specifically talking about the random noise created by your audio interface and its internal components, not external electromagnetic radiation. Ground loops are one of the main causes of hum and buzz in an audio setup. This occurs due to electromagnetic radiation inducing a current in our audio cables and even on the traces of the circuit boards inside our equipment. The topic is quite complex and I'm not going to attempt to explain it in detail, as that would require an entire video on its own. But if you remember your 9th grade physics lesson, you might remember that when electromagnetic waves pass through coils of wire, they induce a current in that wire. So, whenever we create closed loops that can conduct electricity, all the electromagnetic waves that pass through it will start affecting the conductor. And this is what makes your audio setup hum. But by breaking up those ground connections with the transformer, we can significantly reduce these effects. It's debatable whether this is a benefit or an intentional detriment in my opinion. Guitar pickups can output a signal with a peak-to-peak voltage swing similar to that of a line-level signal, but they're only able to create a very small amount of current. To mimic this effect, many Reamp boxes include a high Z output feature, which is a fancy way of saying they stick a great big resistor in the signal path. The intent is for the resistor to replicate the output impedance of a guitar pickup. Except this is a pretty short-sighted feature in my opinion, and only really has an effect with a very specific type of amplifier or a few types of guitar pedals such as fuzz boxes or wah pedals. Most modern guitar amplifiers have a very high input impedance, meaning they draw almost no current and are thus not negatively affected by the guitar pickup's high output impedance. When your sync being whatever you're sending the signal into, has sufficiently high input impedance, the output impedance of the source is irrelevant. In the context of a small-scale signal, it makes no difference whether it's big or small. If your guitar has active pickups, your output impedance is much lower, so active pickups can supply a much higher current than passive pickups. If you use active pickups, you specifically don't want a high Z feature in your reamp box, because it will make your reamp signal behave differently from your guitar. And what if you use an overdrive pedal, or a boost, or a clean buffer, or even a noise gate in front of your amp? Well, those will all have high input impedance and low output impedance, and thus you should not be adding a great big resistor into your signal chain. It will do absolutely nothing useful. Unfortunately, this radial box has no way to disable this feature. A lot of people, and I mean most people, think that this high Z input matching is the most important thing a reamp box does. Nothing could be further from the truth. It's a mere gimmick at best, a detriment at worst, and useful in about 3 very specific scenarios, which you're probably not going to care about. And if you do, take a 20k resistor and 2 jack sockets, solder them together, and you will have achieved the desired effect. Because that's literally all it is. Do not let anyone tell you that impedance matching is the important thing about reamping. So, can we reamp stuff without a reamp box? Yes, you can. In fact, more often than not, you don't need a reamp box at all. It's only if you run into some of the issues that the reamp box specifically helps with that it becomes useful. If you've got ground loops, and if those ground loops are causing hum, because they don't always do, if you've got lots of hiss and you want to improve your signal to noise ratio, or if you're reamping into one of those rare devices which actually react with the output impedance of a guitar, such as a fuzz pedal. In that case, do go and get yourself a reamp box. But if you just want to run a DI track through your favorite high gain amp, then knock yourself out. Just connect the line level output from your audio interface to your amp's input and hit play. Hopefully I've convinced you to give reamping without a reamp box a try. Remember, when someone tells you that you absolutely need something, ask them to back it up with facts. Chances are good that they're just regurgitating old bro science of the internet with absolutely nothing to back it up. If something is said often enough, people tend to accept it as fact. Thank you so much for watching my video. I'll see you in the next one, and in the meantime, have fun making music.